My name is Kai Horstmann. Like I was introduced, I wrote that 2-volume box set there on the left and many other books, and I've seen some copies of the books here, so some of you probably know them. And that's my job, writing these books, and that's why I care about Java evolution, and I want to make you care about it during this talk as well. Björn Strustrup, an inventor of another programming language that should remain unnamed here, it was C++, said, there are two kinds of programming languages, the ones people complain about and the ones nobody heard of. So Java is, of course, the former and not the latter. And so I want to reflect for just a few seconds on why Java has been living for so long. You know, Java has appeared, 30 years ago almost. And so I think one part that Java is still alive and kicking is it was designed as a blue-collar language. It was designed as a language really for the everyday programmer. I'm reminded that not everyone is a native speaker, so in the United States, a blue-collar worker is one who uses his bronze and not his brain, and so they can be productive with Java. It's easy to learn. It's unsurprising. It's supposed to be unsurprising anyway. Another reason that people have migrated to Java in masses is just the vast library that it has. And most of the library is really of pretty high quality. You know, look at some other languages that should remain unnamed, such as Python. Say you want to do something in Python. You have a choice. No, you don't have a choice. You have 10 choices. And now you get to figure out which of those 10 choices is the least bad for your application. So in Java, generally one has tried to say, you know, let the standard library rule. It should contain the one definitive implementation of lots of standard things that people do every day. Of course, we all love Java because it's incredibly backwards compatible. My applets from Java 1.0 still run, admittedly not in the browser, but in the applet viewer. And for many years, to make all of this happen, to have the language stay blue-collar, stay with a vast, high-quality standard library, and stay backwards compatible, there was a very deliberative and formal process to do that management. There was something called the Java community process, Java specification requests. And so people from the entire industry came together, worked on these things, and that's the process the way it was. But that process really is no more. Yes, there still is a Java specification request for Java 13 or 14, but it doesn't have any power. The people just come together and say, yeah, whatever, and that's what it is now. There is a different process, so I want to talk about it, and want to talk about how well it's working for us and what we can do to make sure that it serves us. Just another trivia here, a brief history of Java. So as you can see, Java has been moving along since 1995. The first release was in 1996. And look at a fun fact, 1996, Java was released with, I counted again, with 200 classes. Nowadays, Java has 20 times as much, 25 times as much, but actually it had more at one point. If you look at around Java 9, it had 6,603 classes. The unthinkable happened in Java 10 that the number of classes actually went down. I'm not quite sure why. In Java 11, the number of classes went down by quite a bit because such beauties as Java X, JNLP, and some overlap of the Java SE and EE libraries was purged. And so now it's going to go steadily up, but at a probably a much smaller pace. Also, when you look at the features that were added, I've put the more important ones in big type and the other ones in tiny type so you can't read it. And so you see that there was a few times when momentous features were added to the language. You know, very welcome things such as generic classes in 2004, or maybe not so welcome things as modules in Java 9 in 2017. But mostly the evolution was in smallish updates to the Java language and large updates to the Java API. Now, of course, the release cadence has completely changed. We no longer have these long breaks between releases until something new and momentous arrives, or the marketing people say, well, we've got to have a new language version. Instead, there's going to be a release every 6 months, whether we want it or not. And it's going to be like this. So right now we're at Java, isn't 14 just released? And so we're all holding our breath for Java 17, the next long-term release. And So there's now a new bewildering set of notions for how the language moves forward. There are various projects. There's a project called Amber for small productivity enhancements, a product called Valhalla that I'm unfortunately not going to have the time to talk about, but that's very important, that I urge you to follow, about introducing value types and generic specialization into the language. A project Loom that I will talk about briefly. And there are many others. You've all heard about Graal, the ahead of time compilation, this Panama foreign functions, Color, the J-shell, and Sumatra. I couldn't tell you what it is if you asked me. So each of those projects will issue numerous JEPs, or Java Enhancement Proposals. They're de facto managed by Oracle. There's one IBM person on the committee, and it is possible for outside participants to sign an Oracle contribution agreement and to help in the contribution, but there are not many outside contributors. These are tracked in the JDK bug system, which is a good thing. That means we all can see what's happening. They're discussed on open mailing list, which is a great thing because it means we can all subscribe. And of course, they'll talk about some of the things in a hallway or outside the mailing list. But there is an awful amount of discussion on the mailing list that I really urge interested people to subscribe. There's a couple of things that come out in these off versions that are not LTS versions to try things out, to give us programmers a chance to actually try things out in the wild. There's what's called an incubator module, and we'll see an example of one. That's an example of a non-final API that's going to be given to us in a non-long-term support version so that we can all kick the tires, give some feedback, and then they can change the API if people didn't like it. And then there are preview features. Those are language or VM changes that are, again, of that nature. They're not final. They're there for us to try it out. And so the whole rationale here is that in the past, whenever these preview features came out, people just didn't even bother to look at them because they were not in any version of Java, and by the time they were, it was too late. So now Oracle is making good use of these interim releases, these 6-month releases that otherwise no one has ever asked for. And so they put these features in there so that we can all try them by just downloading the thing and just kicking the tires. And people think it's more serious because it's actually baked in some release, even though it's labeled preview. So let's look at one of those features where evolution has done well. So there's a bug report at one point that says, well, we should do something about car set parameters. So as a reminder, Java 7 introduced the standard car sets class so that instead of using a string UTF-8, we can use standard car sets dot UTF-8, and that way our IDE can autocomplete that thing, and we don't have to ponder whether it was the string UTF-8, UTF_8, or UTF-8, or whatever. So that's obviously a useful little enhancement, and Java 7 made good use of it in a single method. Well, at some point, someone said, well, what about the rest of the API that uses car sets? And so Java 10 then added constructors for the scanner class and for the print writer class that make use of this feature. No, better late than never. Someone noted that there were more of those, and Java 11 then made the same for file reader and file writer. So that's great. And there are a whole bunch of similar small enhancements that are going on. Those are not even put to a JEP. They're simply bug reports, and you can look at them in the bug database by looking for the magic keyword CSR. So if there's something that's always bothered you about the standard library, you could look for it with that, and if not, you could probably propose one. So let's move to a somewhat bigger change, the HTTP client. In 2012, it was announced that there would be an improved version of an HTTP library that was going to soon make it into Java. It was meant to replace the HTTP URL connection that many of us use and hate because it has so many odd corner cases. In 2014, it occurred to someone that this would be a really good place to put in support for HTTP 2. And that, of course, is a good thing because that's not something that anyone would want to do by themselves. And in 2015, one was able to download the first prototype, sadly only for HTTP 1.1, but no worries, it does now work with HTTP 2. 2016, there was some minor API revisions. There was some discussion about what the API should look like, and they were roundly ignored. So the API is basically nice. It's one of those builder APIs. The details don't really matter. You can later look at the slides and see them. But it's a much more pleasant API than HTTP URL connection. It kind of does the job. You make a client, you make a request, and then you send off the request and get a response. There's some handlers to deal with requests and responses in various formats, and it's all a pleasant syntax. There's also, and that's kind of important, there's asynchronous processing nicely integrated into the general Java API. So Java in general has this concept of a completable future, and you can use that to asynchronously send off a request. You get a completable future back, and then you use the normal standard API on completable futures to say how you want to have that handled later. That's a definite improvement over other libraries that were not so nicely integrated with the standard Java API. In 2017, that library was released in JDK 9 in an incubator fashion. So it was in the model jdk.incubator.http client, so that the package name would tip you off that this was not going to be something final. And then people started kicking the tires. Shortly after, the final version was released. So it was moved into java.net.http, where it rests today, with very, very minor API changes. So apparently what they have learned through the incubation process is that it would be better to rename the from string method to off string. There were similar changes of that weight. So it should be perfect now, right? It's been incubated. People have had the chance to try it out. API changes were made, even though they were minor. And is it perfect? Well, not until you actually put it to use. So I've tried to put it to use. And so the first thing I had an example with some good old-fashioned form post with some file uploads, stuff that third-party libraries have supported for 20 years. But no, that wasn't there. So it's 2019, and I still had to worry about URL encoders and MIME multiparts because the people who write this stuff are not application programmers. And unfortunately, no one had complained about it. How about JSON? No JSON, because JSON is not a part of the standard library, so they weren't going to touch that. So you'd have to roll your own to transcode that, which is, of course, doable, but a bit of a pain. What about some of the things you really don't want to deal with, like gzipping, compression handling? No, it's not part of it. There is something in HTTP 2 where when you send a vast number of requests to a server, which you probably shouldn't be doing, that the server can say, well, wait a minute, I don't want those. And but I'll take 20 or something. And unfortunately, there's nothing in the HTTP client that lets you discover how many the server would actually like to have. People have been bewildered by some aspects of the asynchronous part of the library. You can set an executor, and people wanted to do that because when you do a bunch of back-end processing, you don't really want to flood the common fork join pool with that, but you might want to say how you want to have that done. There's a way to set the executor with the method executor. What does it do? The docs say that it sets the executor of what happens afterwards. But actually, that's not what it does. It sets the executor of its own internal code. It's not clear why anyone would want to do that. So there is a bunch of niggling issues about it. And of course, there's good hope that they will all be addressed in the future somehow. But the takeaway is we can't expect miracles from an incubation process. And so if you see how this process worked, there was a very long incubation time when no one paid any attention. Then there was a very short window where everyone should have paid attention. No one complained. And so what we've now gotten as a standard is something that is definitely in some need of further improvement. I don't think it's fatal. All of the improvements that I can think of here could be added on to what's currently out there. So it's not that any roads have been blocked. I just want to put it in perspective how that process works. Let me give you another example where things, I think, have gone a little nicer. Pretty soon, records will be added to the language, not vinyl, but just immutable data. So the poster child example here is we have a record point that has an X and a Y, and that's what a point is. It only has the X and the Y. You can add some methods to it, but these things are immutable. There are accessors that are generated for you, X and Y. So, all of the other usual methods, like equals, hash code, toString are generated for you. So you've seen these things in Scala as case classes, or in Kotlin as I don't remember what it's called in Kotlin. But so these are obviously kind of useful things. You can't add any other instance fields because the state of those is just supposed to be the state of what you put in there on the top, in this case, the X and Y. And so they're serializable. Eventually, there's going to be some support for pattern matching, but that hasn't been hatched. So in other ways, they're basically tuples with names. You know, a point is an int and another int, and it's named a point to give its role in life. And that is very consistent by what's normally done with Java. It's a nominal type. There's a bunch of data to support this. So someone at at Google said, we have a library where one was able to do something like this. One was able to automatically generate these value classes, these records. And so we've looked at our code base, a large amount of code, and we've looked at how often programmers took advantage of it. And yes, they did. They built their, what the Google version of the records were. And they did it about as often as they used enum. Now, enum is a good feature, it's a popular feature, but it's not solving world hunger. I mean, you're not writing an enum every day. But we're all glad that Java has enums, and they're uncontroversial. So here we have some data that says if you give programmers access to such a feature, they're going to be using it actually in exactly the same way. Every feature ticked exactly the same way as the records that were designed now for an upcoming version of Java. And programmers liked them, they used them. It didn't solve world hunger, but it was an uncontroversial feature that was considered useful. So when these things are now going to be added to Java, then that's going to be a good thing. Now, there's always a few people who want this feature to go beyond the scope, and the Java folks say, no, this is a limited feature. It's like enum of that scope. We don't want it to solve all Java boilerplate problems. It will just do what it does. And it will appear soon. It may really appear in 6 months or maybe in 12, depending on how things go. So that's kind of baked. There was a discussion process. Things were mostly uncontroversial. There were a few people who said, well, wouldn't it be nice if we, even though these things are immutable, if we could have kind of mutator-like things that produce a new object with a single field changed. And for now, the saying is, let's start without that. That's always something one can add in later. So here you had a publicly visible discussion. A feature set was developed out of the expertise of the people in the project that matched pretty well with actual experience elsewhere. And it's going to be released pretty soon. So that's kind of how the process should work. I'll give you a different example. In January 2018, a JEP came out about raw strings. So the idea was that if you had a foreign string that comes from SQL or Markdown or something, you should be able to just dump it into a Java string without having to worry too much about escape sequences. You know how it is a pain today. You have to do escapes. When there are new lines, it looks ugly. You want to break it up into multiple strings with plus and so on. Yeah, the IDE can do it for you, but it's not something that you really want to have to deal with. It was explicitly said, this thing is not going to deal with interpolation, with variables that are embedded in the string, and it's not going to deal with like formatting or something like that. So it was simple and ingenious. The general problem that you have, if you have a string in some other syntax, whatever that may be, is that you say, well, I'm going to start out with, say, triple double quotes. But what if the string also contains triple double quotes? Then it's not going to work. So they came up with the following. They said, we're going to be using as our delimiter the backtick, because it was the one delimiter that was still freely available. And, well, what if this thing that you want to put in there has backticks, like it might in Markdown? Well, let's say that it has at most 3 backticks. You have some Markdown with at most 3 backticks. Then you just put 4 backticks, and at the beginning, your Markdown thing, and 4 backticks at the end. Will work like a charm, right? If it had 4 backticks, you would put 5 or 20 or something. So that way, no matter what the content of the string is, you can always add 1 more backtick, and it'll work. There's a teensy little problem that the string that you're putting in cannot start with a backtick, because if it were to do that, then you wouldn't know whether that initial backtick is a part of the delimiter or not. So I politely asked, why not make it so that you have your so many backticks and then an enter, and that's the starting delimiter, and then the other backticks as the ending delimiter, and then you could have a string that starts with a backtick. I got no answer, unfortunately. But so let's hold that thought, because there's a much bigger issue. So here I have an example of one of these little strings, my name in a box. Clearly something that looks much more pleasant in this way than it would otherwise. And now, there is a problem that was perceived. People said, well, if I have that string, string my name in a box, and then I have the string, wouldn't it be much nicer if it looks like in the second code block, where it is neatly aligned with the rest of the code? Okay. And so I looked at that, and about 15 seconds, because I'm old and slow, the thought popped into my head, well, what about tabs? What if the first line happens to have a tab? How are they going to know what's the common prefix? Because, is it 4 spaces a tab or whatever? And I wasn't the only one with that question. So at first, the idea was, well, we'll make it so that if we look at all of those prefix sequence, and if they have the exact identical contents with spaces or tabs, that's the common prefix. They will get stripped from the string, and only what's left over is what's actually the raw string. After a while, people said, well, that might not be so nice because you can't see the tabs, and the current proposal was that, well, every Unicode whitespace character, whether it's a tab or a space, will count as 1. And as long as it's the same number of spaces, vertical tabs, by the way, work as well, then I'm not making this up, then they get stripped. I thought that was kind of crazy. I mean, we've gone through that route before with Python, where everyone realized that that was probably a big mistake. So I followed that discussion, and after about 400 messages, I saw this beauty where one of the people said, well, here's this pattern that I tried to describe that was poorly handled by some case, but sorry, my mailer messed up the white space. And so I would think that if you discuss something like this for hundreds of emails, and you can't even get your mailer to preserve the white space, what makes you think that preserving the white space in your Java code is a good idea, and this would be summarily dropped? That is not the case. What came next was text blocks. Yes, JEP 326 was withdrawn for all the wrong reasons. Someone said, and that discussion was actually there before, and wasn't taken too serious until they looked for a reason to withdraw this JEP, that if you have 2 backticks, it looks like an empty string and not like a starting delimiter. Would have been an easy thing to deal with that. Someone said, well, you can't have raw strings starting with a backtick without looking at the obvious remedy. And someone said, well, it's a waste of a backtick character, and this is a fine character that we might have better use for later. And the argument was that any number of quotes thing might be confusing to the IDE. If an IDE is confused by that, what do you think it's going to think about your code? Anyway, now we have a different JEP about text blocks. So text blocks are multi-line strings, which is nice. So they can have embedded new lines. They're not really raw, they're more like medium rare. So you can have escape characters in them, but hopefully not too many. So here's an example. So they start out with a triple double quote, like in many other languages. Well, what if you have more than 3 quotes inside the thing that you want to embed? Then you have to put a backslash in there. Well, that's bad news, because it now means that if you have a backslash, which is not an uncommon thing. Think of regular expressions, path names, SQL, or whatever. I mean, it's often that you have the occasional backslash. Now you have to escape the backslash. So you can no longer just drop in your stuff from some foreign source into a Java string, but you now have to massage it. But notice that this time they wised up and they did ask for the new line after the triple double quote. But they still persist in the madness of stripping prefixes, whitespace prefixes, and for good measure, now they're also stripping, and I'm not making this up, now they're also stripping trailing whitespace, because it's good for us. So you want to have more control over that process? There is going to be more escape sequences that you can add, and you can put in a \s for a white space that is dear to your heart that you don't want to have stripped. So this is actually shipping with JDK 13 as a preview feature. And so I encourage you to use it in your code and to send hate around the world, because that way there's some evidence generated that might make people rethink. So yes, it's multi-line. Does it handle that one common case of dumping foreign code into Java? No. You still have to worry to escape it. Can it do other things that are there in other languages? Interpolation? No, they didn't even try that. Or things like embedded formatting, like in message format or something. No. So there you have something where the process didn't really work. There was a long-winded discussion about features that probably not that many people care about, and not much attention of the features that people did. And we're now coming up with something that I think is plainly suboptimal. Can it get worse? Well, let's have a detour before addressing that. So in other languages, we have, of course, much more advanced features than in Java. And one of the stated goals of Java is to catch up with the useful parts of those other languages. For example, pattern matching in Scala. You can do all sorts of things. Of course, you can do what you can normally do in a Java switch statement. You can have type patterns where you can match whether an object is an int or a string or a big int and branch off that. You can, in the match, extract pieces of the match. Like if you match an array, you can say, and I want to have the first and second elements labeled with some variables. And then that extraction syntax carries forth to elsewhere in the language, outside the actual match, so that you can define multiple variables through this destructuring kind of syntax. So that's all nice. It all hangs well together. And it's something that Java definitely wants to have in some form. So JEP 305, which will be soon a part of the actual language, gives us a simple flavor of this. So here you can see this instance of statement that will now be gussied up as followed. Instead of just saying instance of string, you put a little s after that, and that's the variable that now is the same as obj, but it is typed as a string. So afterwards, you can invoke string methods on it. And so there's some amount of trouble to make sure that this works. Here, for example, you see that and operation, and so that s is in scope in the second half of the expression, so that you can already use it right in with the and, but of course not in scope before that. So that's a pleasant little thing that's going to make instance of nicer, because we no longer have to first do the instance of followed by the cast. Better syntax for this little edge case. And then there's a whole bunch of white papers about that we want to extend this thing so that we can match points and deconstruct them and match types and all of that good things. And that's, of course, something that we really do want. We know from languages such as Scala and Kotlin that those are popular features that programmers use all the time. So here's now a first aspect of that. It says, well, one thing that you really need for this to happen is that when you have a branch here where we're testing whether some value, in this case this would be an enum that I didn't declare here, so day is an enum, where you have some value and you want to now test multiple cases for that, then you want to have an expression. That's how it works in Scala. The very first Scala thing that I showed you was this kind of expression where you just switch on different values. And so the syntax is going to look like this. No, nothing wrong with that. So you have cases, and then the little arrow thing tells you what the value is for that case. The whole thing is an expression, so you can assign it to a variable. So here we say int num letters equals the thing to the right, whichever it's going to come out. That branch selection has to be exhaustive. So, because it wouldn't otherwise make sense for an expression, right? If you omitted Wednesday, then what would it do? So that's nice and simple. So it's an expression, and it's kind of like a souped-up version of question mark colon. You have if, that's a statement. You have question mark colon, that's an expression. So it's kind of like a multi-way version of question mark colon. Sure, other languages have it. Java wants it. Notice that there are expressions to the right of the arrows, because after all, that's what we want to evaluate. There's no fall-through. Switch has that stupid fall-through. That's a case of more grief than goodness. And so this doesn't happen here because it doesn't really make sense for this context. Like I said, it must be exhaustive. You can't have a default branch. And so the pitch for this is that these changes, as quoted from the JEP, will simplify everyday coding and prepare the way for the use of pattern matching, which is a good thing. We want pattern matching. And so this was delivered as a preview feature in JDK 12, so maybe you've already tried it. Now, there's a teensy tiny change that I'll come to in a minute, with which it is in JDK 13. And it is now targeted as a standard feature of JDK 14. So what's wrong with it? Let's say that you have a case where you want to do more than just evaluate an expression. Let's say you want to log that you're in this case. Then you kind of have a problem, because on the right side of the arrow, you're supposed to put an expression. Well, could you put braces here, like I have here, where I first do my logging statement and then return 7? Well, that's not valid Java syntax, because in Java we don't have this kind of block expression. In Kotlin or in Scala, that wouldn't be a problem, but in Java we don't have that. And in fact, lambdas have always suffered from the same problem. When you have a lambda expression, you can say x maps to x times x. You have an expression on the right. But what if you need to do more work on the right? Well, then you need to put braces, and then you need to put in a return statement. Why did they put in the return? Well, they didn't, for some reason, want to have block expressions at the time, and in the context of Lambda, the kind of function is the return seemed to work okay. And so we could, of course, do the same thing in switch expressions. We could put in a return 7 in here, but for a switch expression, that would look pretty weird, right? You have a return in the middle of this switch, in the middle of a method, and it doesn't return from the method, but only from the switch. No one liked that idea. So since someone came up with a much more ingenious way of saying, well, let's use break. When we say break 7, that means we're going to be leaving the switch expression with like an impromptu kind of returnish kind of thing with the value 7. And there's some problems with that syntax that, of course, were gleefully raised by people who create puzzlers. Like, what if you say, in this case here, where we're inside a for loop that's inside a case, and then, of course, it would have to would be an error because a break in there would have to mean that you have to go to the for loop. Or anyway, that was the resolution of this. Or what about this beauty here, where you have break followed by a variable name? Well, is it a variable name, or is it a labeled break? And so resolutions for all of these situations were devised, and they were tried out in JDK 12. And you probably all tried it and complained about it, because in JDK 13, the entire complex machinery was retained with a single change. Break was renamed to yield. So now, if you want to yield a value from a switch expression, but from no other kind of expression, you get to use the keyword yield, because break turned out to be just too ridiculous. So it gets more interesting. Remember poor old toxic statement switch, the thing with the fall-throughs, and that was never any good. It's still there, of course. But maybe you wanted to sanitize your statement switch, and now you can. You use the arrows, and here you go. So now you get a not-so-toxic version of statement switch. But evolution is not a one-way street, because what you also get is a toxic version of expression switch. You want expression switch with fall-through? You asked for it. Well, no one actually asked for it, but here it is anyway. So that's what you all get. And so the way that it's being explained to us is with this matrix. So the matrix has two axes, expressions and statement. And you would think the other axis would be toxic and wholesome, but that's not what it is. The other axis is no fall through, and fall through. As if anyone has ever asked for that access, but we have it. And so you have these 4 variations, and so now you have a nice switch here that we actually want. We have, on the other side, we have the old switch that's always going to be there. And then we have two new ones that no one ever asked for, but here they are anyway. So why is this? So the rationale that's been offered for this really complex and arcane arrangement is it seemed more desirable to tease the desired benefits, expressionness, better control flow, saner scoping, I didn't even talk about scoping, into orthogonal features so that switch expressions and switch statements could have more in common. The greater the divergence between switch expressions and switch statements, the more complex the language is to learn, and the more sharp edges there are for developers to cut themselves on. I can't count the sharp edges that the feature as soon going to be released is going to have, but I'm okay with that. I'm a book author. The more complex the stuff is, the more money I make. So let me show you another matrix. They can make up a matrix, and so can I. And here is a matrix. On the top you have statement and expression. On the vertical, you have two-way branches and multi-way branches. A statement, two-way branch is an if-else. A statement multi-way branch is a switch. An expression two-way branch is a question mark colon. We all know question mark colon. And so an expression multi-way branch, okay, why again is it a switch? The whole premise that there should be switch expressions is wrong. No one has ever said there should be switch expressions. Sure, there should be multi-way branch expressions, and they could have any syntax that we care to devise. Here, I just made one up on the fly, where I call it question mark colon, because it's multi after all. But you all can think of your own syntax that would make this work. And you could cook up a perfectly nice multi-way branch expression, as every other language other than Java has done. Look at Kotlin and Scala. They have those things. There's a good reason why in Scala the thing is called match and not switch, because it isn't a switch. And it shouldn't be a switch, because our ultimate goal is pattern matching. Switch is there for one reason, to make a faster jump table so that you can make a computed goto, or if they're not contiguous, at least a binary search. And that's something that you could not effectively code up in the host language, like in C or Java. Patterns are not necessarily constant. They're not necessarily, but they are necessarily sequential, unlike switch. So they're just a different animal. There's no sense in artificially conflating them, yet here we are. So this is another case where the process, I think, had issues. And more people should pay attention, because if you look at how fast these things sail through, it's amazing. This thing is proposed, there's some vigorous discussion, then it gets baked into a preview feature, then tiny, tiny changes are made, and pretty soon it is in the language. So if you care about these things, it's a good idea to follow them early. So let's look at one last project that is just at the start, and now would be a great time for everyone to look at it. That's Project Loom. So this is all about a kind of concurrency. So in 1995, Java was revolutionary by actually having native support for threads built into the language. In 1997, the world went nuts when they saw that the Java web server was able to run each web request in a new thread and not in a new process. It was amazing. Thousands of concurrent requests. Of course, today we laugh at thousands of concurrent requests, and we know we can't afford to have a new thread for every incoming request. And so what are you going to do? That means that you can't ever block on a thread, because that would just waste that thread from you. And we come up with asynchronous programming. Instead of blocking, we say, well, when that long-term and slow thing happens, I'm now going to tell you what you come later. And you get things like callback hell, or futures, or async await. And so Loom says, we really don't want async await in Java. Async await is not a panacea. Now, it's difficult to program for. You now have two classes of functions, the asynchronous ones and the regular ones. Yes, programmers can do it, but they don't love it. So, and ultimately, the root of all of this is, why does blocking have to be expensive? In Erlang, blocking isn't expensive. And there are other languages where blocking just isn't expensive, and where where you don't map every concurrent task onto a separate thread, but a single thread can execute many concurrent tasks, and when one of them blocks, it gets parked. And so that's what they want to do. So we should have millions of concurrent fibers. A fiber can run as is executed on a thread, but a thread can run many of them. And if if one of them blocks, then it should be free. The fiber gets parked, the thread keeps chugging along with other things. This is not something new. And other systems have done this for many years. And so the Loom people said, by bringing that to Java, we can bypass that kind of detour of async await that you see in other languages. So the idea is to make concurrency easy again. But before we say that, it's not going to solve all concurrency problems. There are more than one reason for concurrency, like in user interfaces. Why a user interface is single-threaded? Because no one could figure out how to get the UI to be thread-safe. And so the single UI thread simply serializes all of the operations, and it's kind of more of a matter of convenience. And fibers wouldn't help you with that at all. So you're going to be using, if you're an Android programmer, async task for some time. Remember, a few years ago, we all heard that parallel streams are going to be solving all our threading problems. Well, that was, of course, never really true. Parallel streams are great for certain workloads. So if you have a heavy-to-the-metal workload that splits nicely because the data structure is splittable, then parallel streams work great. Well, if the threads block, then, of course, that doesn't really work. With fibers, I suppose you could use blocking fibers as long as the data structure that you operate on splits well. So it might extend the utility of parallel streams somewhat, but really they're not meant for computationally intensive tasks. What they're meant for is this kind of situation where you have requests, many, many more requests than you have threads, and you want to deal with them when you have to do some blocking work. So you can get this today. They do release every once in a while a preview release, but I suggest you just build it. It's easy enough to build. So I built it on a Linux system in 15 minutes by just copying and pasting these commands from the README. And then I immediately said, well, what can I block on? Well, like sleep, right? So I made 1 million fibers that where we'll just sleep in each operation, and it worked just fine. So it made the 1 million fibers. Just out of curiosity, I hadn't done this for a while, so well, then let me just use threads instead of fibers. And so after about 10,000 threads, my laptop died out of memory. Yeah, I could have given it more memory or something, but the idea is that you can here very easily run 1 million threads, and obviously it has been instrumented today so that sleeping will work. When a fiber, I should say 1 million fibers, when a fiber sleeps, it gets parked, other fibers can use the same thread, and so that part works as desired. Now, the next thing they want to do, and I think that's a very good idea, is they want to give us what's called structured concurrency. So if you've never read this blog article, I'll make the slides available so you can find it. You should definitely read through it. So this guy, Nathaniel Smith, says that one of the reasons that concurrent programming today is hard is it's kind of like programming with Goto in the bad old days. So when you run a new thread, or in Go, when you run a Go routine, you just kind of go into outer space. And afterwards, it's hard to reason what your program does. That's something that in the 1960s, with a regular Goto, we have solved. We no longer write Gotos. We write structure statements, branches, loops, function calls, and so thereby we have regained the control that was lost when Goto was a part of every language. And so Smith says we should do the same thing with concurrent tasks. We should not just have them kind of randomly go in outer space and then later worry how they're going to synchronize again. We should make it so that when we split a task into multiple concurrent tasks, that we say right away when they're going to meet again. And that way we have control over resource deallocation, cancellation, and so on. So this is how it looks like in the Fiber API, really quick. And these things are going to change, so I'm not going to really deal with it very much. So we're going to make what's called a Fiberscope. We're scheduling a bunch of tasks in them, and then we're going to close the scope, and that's this rendezvous point where this blocks. Now you might say, oh my God, it blocks, but remember, blocking is cheap in this world, so it doesn't matter really that it blocks. It'll just block until they're done. So the programming model is dead simple. You can really understand it easily. Yeah, by the way, you can use a try with resources. What if some of these tasks don't finish? Well, you can give it a timeout or a deadline for it by baking that into the scope, and so as soon as the deadline has passed, everything is going to get canceled. How does that cancellation work? It kind of works like interruption, but with a slightly saner API. So instead of interrupt, you cancel. Just like with interruption, it unparks parked fibers and throws in an exception. It's cooperative, just like with interrupt, because that's really the only way that we can do it. And so just like with interrupted, there is a cancel that you can call. And when a scope times out, like I just said, all the fibers are canceled. You can't uncancel something like you can do with interrupt, which is sane. So like I said, it's a saner API of interruption, and it's there now. You can try it out. So I don't want to go into these details, but I did try it out with this one example. Heinz Kabutz gave this nasty example in jQuery. He blogged about it. It was about fetching lots of Dilbert cartoons. Again, the details aren't important, but the important thing is he did it with completable futures. And here is a simplified version of the pipeline that he had with completable futures. It didn't work, and so he asked, why didn't it work? And we did figure it out in the end why it didn't work. But it was a mess because of the completable futures, and it's just hard to follow them. I wrote it up with fibers, and with fibers it's dead simple to see how it follows. Namely, you get the web page, you find the URL in it, you get the image in that URL, and you show the image, and it worked like a charm. So that's a pitch of fibers. It makes your code easier to read. We didn't care that it blocked. Yeah, we read 10,000 images, and so there you have an example of why they're useful. So I'm not going to get into the API, but there's a bunch of interesting discussions on whether fibers should behave like threads or not, and I have strong opinions about them, but I want you to have strong opinions about them as well, and that really is the point of my talk. Namely, like I said, it's all of these things, that this is a project that is in its early stages. They're still working on it. Lots of stuff doesn't work yet, and so no sane programmer would touch it, but I want you to touch it anyway, and look at it, and find out what you hate and what you like, and let them know. So now is the time to get involved, because by the time that this is going to be baked into JDK 23, you only have until JDK 24 to complain that you didn't like it, and so now is a much better time to do that. And that is really why I've given this talk. Java is not done. It's not going to be done for a good long time. There's lots and lots of other things that are also very interesting. Valhalla, Panama, and all of those projects. Some of you will really rely on these things to be done well. There's also other features that are maybe not so important, and yeah, maybe it's okay if they just turned out to be kind of crummy, but on the other hand, it does detract from the overall quality of the language, so I think we do care. And so in this process that we have, it's not clear to me that your and my interests are always represented. Maybe my interest as textbook author, who loves complications, but not your interest as programmers. So they really need you. And so read those chapters. You can't read them all. Now I have to, because I have to write these books, but you don't have to. Pick one that's close to your heart and get involved. Read those project pages. They're fairly accessible. And try those early builds. They tend to be fairly easy to deal with. Write a blog about them. Give feedback. Go to the mailing lists. Make your opinion known on blogs. It actually does work. I've seen mails that say, this guy said this is a terrible feature, we should pay some attention. Or this guy says it's a great feature. It validates our approach. And if you can at all swing it to get some data, if you have a larger project where you can run some of these things on, or where you can say, well, I could use in 2% of the methods, I could apply this, and this is good for me, or it means nothing to me, or something. That kind of large-scale feedback is great. Like the guy with the records. That completely validated the approach. It shut off any unnecessary discussion. Conversely, if you say, well, no one would ever use this, and here is why, and you shouldn't waste time on it, that's also valuable feedback if you can do it with actual code. So that's what I want you to do. Go and pick your favorite thing that's going to be in the future of Java, just one thing that you think you will really want to use or you would never want to see in the language, and educate yourself, wheedle your way into the mailing list, write blogs, and learn about it, and if at all possible, try to get some data for it. If we all don't do that, we're all going to get what we're going to get. Thank you. I don't know, do we? I mean, I'm here. Yeah, absolutely.
All right, so guys, if you have some question, we can ask our speaker right now. Just a few minutes, that's why we have just for a couple of questions. Do we have somebody? Please raise your hand and we'll give you a microphone. Anybody? Still nobody? So I think that all was very clear. Yes, I mean that about all your talk. That's why, thank you very much one more time. And now we have, let's give an applause, yes, why not?